I wasn't either, but I mean,
Kyle is 24. And
5.
I had to
Fuck.
make the crack.
You ready to go, Joey?
I was born ready, Mr. Chair.
Hit it.
Oh, okay.
All
Well,
right.
it's called 3D printing, the why and how. So, I kind of looked a little bit at what people had already done with 3D printing. It seemed like there was kind of a little bit of everywhere. Some people hadn't done anything. Some people may have watched a video or two, and it seemed like some people had ordered 3D parts, or maybe they just did like I kind of went through the process, but I don't really know how it works kind of thing. So hopefully there's a little something for everyone. I'll try and make it like an overview with little bits of detail as necessary. So, any questions before I get into it?
Are you gonna go into depth of like I know that printers use, I think it's called HPGL language.
G code is
G-code.
usually, at least that's how I call it, G code, because those are the files.
Okay.
We can look a little bit at that, because that, as programmers, it's kind of cool to look at that.
Yeah, I was just curious if what the 3D printers use is similar to, or the same, compared to like a normal printer.
Yeah, we'll look at that. Okay. Sweet. I wasn't planning to do that, but that's cool stuff to look at. So. Okay. Okay. 3D printing. I felt it necessary to show why you would want to 3D print, though I think some of the reasons are self-evident. There are obviously practical purposes. I'm not sure how practical a deadlock made out of plastic is.
I was just going to ask that.
maybe if for like a small child, maybe.
I mean, it's better than nothing.
They also do metal 3D printing, if I'm not mistaken.
Yes, those ones are really cool.
I mean, if you're facing down an army and you've only got a single tank, you use that single tank.
That's true.
Yeah. The 3D cast was actually one of the cooler ones that I've seen. Other things are like fixing little parts around the house. I think I've seen 3D prints for like O-rings and parts of like plumbing systems and stuff like that. I had my case for my phone 3D printed, which was kind of cool. So lots of practical things.
Interesting use case.
It's a good use case. The other ones that I think are just more entertaining, you can make cheap artistic objects. And for nerds, the best one is miniatures. You can print miniatures for like 5 cents. That would cost $3. So that's pretty good. And then the other thing would be making parts for things you might already have that just plain don't exist.
That's a good idea. 3D print your own Legos, because the real Legos are so expensive.
Or you could 3D print guns.
That's true. They did do that.
I
just want to interject because I have recently I got it's like this RS-232 and compact flash thing for the TI-99, and I had a friend of mine 3D print a case because they were charging like $40 for the case, and there's no reason for that because it's like 5 cents a thing, so you can make stuff very cheaply.
Yes. I think my case cost about probably 5 to 10 cents instead of at least $3. So it's a pretty good return on investment.
Oh yeah, and if you get like a
Brendan.
small one, one, a portable one, you can take it to hackathons. I saw that one time in New York.
Ooh.
Yeah, Rochester.
Okay, that's actually pretty cool.
Yeah, it was really cool.
Really all you need for them are a couple good servo motors, and those pretty much determine how well it's going to work. And there's a couple other things, but we'll get into.
Brendan?
Yeah?
Are you playing Warframe, Brendan?
I don't know. Why?
I saw the Steam alert pop up.
Hi, Brendan.
What is this Warframe you speak of?
I played
Oh,
with
boy.
you, John. Do you not
No,
remember?
no, I'm trying to play around. Like, what is this Warframe you speak of? What would a mere mortal, know of this Warframe?
Okay.
Yes.
Back on the rails.
Yeah, Ruby on Rails. Okay, so the real
Nah.
question is why not 3D print? And there's a lot of good reasons not to. For instance, if you need to print a lot of something, it might just be cheaper to make molds of it. Also, depending on the material and what it's going to be used for, sometimes 3D printing isn't as structurally sound as it needs to be. In case then maybe you have to go to the metal 3D printers, and then that can get expensive. So it's may not always the best, but it definitely has a use case.
Be right back. That stuff.
Yeah. So the process of 3D printing is really, I broke it down into these 5 steps, kind of like how you the process of software development. You have an idea. With that idea, you make some sort of model. With the model, then we have to go to, as Josh was kind of talking about, the G code. We have to have some code that the printer is going to run to know how to print it, because the printer can't just see a model and print it. There's a step in the middle. And then once we have the code for the printer, we put it on the printer and actually, make it. And then we repeat the steps as necessary. So if there's some flaw in it, maybe we can go back and figure out, okay, do we need to change some settings on the printer? Do we need to change something when it's making the code? Do we have to change something in the actual model itself? For me, our idea was stupid to begin with, and we should change that.
Yep.
Yeah. So you should always be willing to figure out which step you need to go back and fix. But this might be a little weird, but I thought the best idea would be to start with how you actually print it and then work our way backwards, so that you can kind of figure out like the end goal in mind as we figure out all the rest of the steps. So how do you actually print something on a 3D printer? For those of you who have never seen something 3D print, oh, there has to be an ad. Okay.
Ad block. Do you not have ad block?
No, I like supporting things. So you can see in this, let me mute it. What we have here is essentially, it's a time lapse, but it's doing it one layer at a time. And this is kind of the key that you really have to understand about the process, because from this, there's a lot of issues that can come and things you have to understand mechanically. But this process of printing it in layers one at a time, going around the entire layer, making that layer, and then moving up one layer and printing that whole layer, and then moving up one layer and printing that whole layer, is one, it can be time consuming. But the other thing is there's the structural integrity that you have to think of while it's printing. Because not everything's going to print exactly the same. And obviously we can't just print in midair all the time. And so what implications does that?
It has to be able to hold itself together at all steps of the printing process and possibly even afterward.
Do you have to specify the supports, or can you have something that will automatically figure that out?
We are going to look into that. And the answer is there are things to automatically put in supports, and there are things you could do to put in supports yourself.
Nice.
Usually the automatic ones are more than sufficient. So
hey, Adelic.
Yeah, so you can do cool things. But that was kind of the process. I hope it made sense. The idea of doing it in layers. Yes. And so I guess this is more of a zoomed in view of what's going on. So we had that filament, which is just the plastic. There's a bunch of different types of plastic, and those basically get fed into the extruder here. There's a stepper motor with some teeth on it, so it kind of grips and pulls in more filament as you need. In fact, this is what determines the stepper motor up here determines how much filament's going to get pressed out. Because obviously there's only so much space in here, so as you put in more, you're pushing some out the end. Essentially, it gets heated here. The temperatures for like an average plastic anywhere from 180 degrees Celsius to 210 Celsius. Depends on the material. And then, so basically, then we're feeding it in here, and you have a very specific size hole at the bottom that it gets pushed out, and then you see it builds it one layer at a time. So I think that's the main thing. So does this make sense? The idea of just pushing it out and building it one layer at a time.
It do.
Mm-hmm.
Okay. So, like we were talking about, the idea of having it just print in midair really doesn't work, because when we look at this, it's hot. It's still 180 degrees Celsius. It's pretty hot, and it's very flexible as it's printing because it's really a liquid at that point. And so if it's hot and in midair, it's going to droop until it cools. And so here you can see, the farther out you're printing, the more likely that hot is going to have nowhere to go but fall. Interestingly, though, as you keep doing it, it does have an amount of area that can hang out, depending on how you get your temperature settings just right and how well you're cooling it. Because a lot of the times what you'll do is you'll have a fan that's blowing on the plastic as soon as it comes out, which will cool the plastic faster, and that allows you to do better kind of overhangs like you see here. But obviously that can't be a perfect solution to just try and cool it as best you can. If you just do that, you're always going to have issues. And so, like Brendan was mentioning, you can have supports. And you might say that it's part of the piece, but really, when we'll dig into it a little bit, but when you look closely at it, they're actually really loosely connected to the part itself, and that allows you to basically snap these supports off. Hello, Ben.
Hello. I'm taking a discrete test, so I won't talk, but I'm here. Yeah.
I understand. We'll exercise discretion.
Good luck.
Yeah. But yeah, so these are the supports which can be automatically generated. Theoretically, you could build them yourself if you really wanted to, but that's pretty much unnecessary at this point. Yeah, I think that's the whole looking at the actual print. So if there were any other questions on actually printing.
Do you know what the finest resolution that you can get on, like, I guess, typical printer that a human being with a job would buy rather than
so
like industrial?
The cheapest one that I think is the common one that most people that's a good starting point, is the Ender 3, and it costs what, $250, which is an amount. It's not a ton comparatively to the $1,000 printers. And you can look at layer heights that are, your layers could be as thin as, I think I've seen 0.08 millimeters in layer heights.
Okay.
And then
ran into my computer and crashed my computer.
Nice.
It's actually on sale for 180 right now. So.
Ooh,
Really?
nice.
Yeah.
And then I believe
What did I miss?
not much. This sums up everything you missed, I think.
Okay.
Ooh, nice link. Let's see. Does it say how? I can't remember exactly what the. Yeah, so layer thickness, it says it can go to as thin as 0.1 millimeter. I think I've put ours down all the way to 0.08 millimeters.
Okay.
Which is 80 microns.
Oh wow, that's
and
actually...
yeah.
Yeah, because I think the AMD processor structure is like 7 microns, right?
Nanometers.
Oh, never mind.
Just a little difference.
Little different.
Guys, okay, never mind.
And the other measurement, so that's the layer height. The other measurement is this width here at the nozzle. And for the entry level, the Ender 3, it's 0.4 millimeters. And you can change that out. I think I've seen some that go as small as like 0.2 and 0.1 millimeters. And you can just buy those, and a lot of times you can fit them already onto your machine as just an upgrade. So,
fancy.
Yeah, so you're looking at like 0.1 millimeter by 0.1 millimeter, or 0.1 by 0.4 for how small of a dot you can put down.
Man, you've really got this on point.
Okay.
I'm sorry.
I need to make a soundboard of all of the CSE sounds, and Joey's sigh is one of them.
Okay.
Yes.
So this is how you actually print. So why don't we look at how do we go from a model, because you can get the model from a lot of places. How do we go from the model to the printer? Making the code. Okay. Perfect. Nice. Gotta have the reminder slides. Okay. So, I'm gonna show you how to do it. There are pieces of software called slicers. And the one I use and a lot of people use is called Cura Ultimaker, or Ultimaker by Cura.
That's the one that they use at the ThinkBox.
Yeah, there's other ones. If you just Google slicers for 3D printers, you can load up a bunch of them. I don't know why this one's taking so long today. And there's a bunch of different software packages. Some of them cost money, some of them are free, some of them are cloud-based, so it actually does all the processing on the cloud. Kind of cool. So this is what it looks like. You set what printer you're using. So I'm using the Ender 3 because that's the printer we have. And then all you gotta do is load the model. So as a basic example, we have here a headband.
I thought it was gonna be Luke's banana.
No. I mean, we could look at that, but we printed about 200 of these. And so there's a couple things you'd think, how much technicality is there once you have the model. And so you'll notice on the side, there are a lot of these little settings. But I think it's first to start off, obviously, we can move this around the build plate. We can scale it, make it small for like little kids, make it bigger for like, a normal person, even bigger for like me. We can rotate it, I hope you can see where you go with that. You can mirror it. Ooh, we can mirror it this way. Do you see the differences?
Fancy.
So that's all good stuff. So what is all this crazy stuff on the side? Because every one of these has a bunch of settings within it. And in all honesty, if you never knew what these were, it really wouldn't matter. You would still be able to print things. You might have issues with your prints, and then you can figure it out as you go. But as you can see right at the top, they usually set profiles to easily just click. One says super quality, one says dynamic quality, one says standard, one says low quality, and you could just pick one. You can hit slice, and you can figure it out. But I think we're all pretty techy, so we might as well be able to dive a little into it to see what they really mean. And the biggest one to know is next to each of these. I don't know if you actually can see this because I don't know how good the resolution is.
Yeah, we can see it.
I can see it, and I have bad eyes.
Okay.
I also can see it, and I also have bad eyes.
Awesome. So next to each of these qualities is a different number in millimeters. where it's saying the super is 0.12 millimeters and the low quality is 0.28 millimeters. Does anyone want to make a guess as to what that millimeter measurement is?
Layer height.
Somebody did their homework. Wow. Yeah. The thinner the layers, the higher quality your print is going to be, because every layer you can add a little bit more detail to.
If your layer is thinner, it's less likely that someone's going to be able to notice the layers at a glance.
Yeah, sometimes. Yeah, definitely. Sometimes if you go too thin, though, and a printer can't handle that thin of a layer, like if the stepper motor isn't like able to handle the fine increments, then you end up, spitting out too much and it kind of blobs up. But as long as you're in tolerance of the machine, yeah, thinner layers are going to be harder to see. The other things, so that's kind of the quality. As you can see, when we went to the low quality, it set the layer height to 0.28. You can kind of go in here, and a lot of these are kind of self-defining what they are. Like the initial layer height is the height of the first layer. Other things to look at or to think about is, well, we really didn't care much about the quality of the headbands. As long as it's one piece and it'll hold the face shield in front of your head, that's what mattered. So we wanted to crank out as many of them as fast as we could, because speed was the importance. And so while you have lower quality with thicker layers, you also print a lot faster because you have less layers to print. So there's kind of that trade-off there between precision and speed, as there always is. So you can change layer heights to change the speed and to change the speed of the print and the quality of the print. You can also, the other common thing to change would be the printing speed, which is how fast that extruder will move around the space to print. And usually it's set to 50 millimeters per second. I think when we were printing these face shields, we had it up at, I think we got it to 80, maybe even upwards of 100 millimeters per second. So it was just like zipping around.
Millimeters being the amount of plastic used?
Millimeters being physical in space, not plastic. Because the amount of plastic being extruded is determined by the distance and layer thickness.
Well, like the thing that's getting me is, and I think it might have just been that I completely lost you somewhere. Millimeters aren't a unit of space, and that's what's getting me. Do you mean like the height of the model?
Like distance along the build plate.
You see the grid on the bottom of the plate?
Yeah, that.
That's what
Yeah,
you mean.
each grid on the plate is 1 centimeter by 1 centimeter. So.
Oh, okay.
Yeah.
Okay.
Yeah. Okay, this is kind of a important but boring model. So let's pull up a more exciting model.
Banana.
I don't think I have the banana on my computer. What do I have?
Go to Thingiverse.
From Thingiverse. I have this one.
Is
file.
3D printing playing cards a super bad idea, or is it just me?
Playing cards
I hate it.
are better on paper.
I hate it a lot.
You hate the spider?
I'm an arachnophobe.
Okay, do you want me to change it?
I am too, but that does look adorable.
I'm not that bad,
those are
but
two
I hate
totally
it.
opposite things to hold, John.
Look, I can be scared of spiders, but admire their majesty.
Where'd the dice go?
That's true.
Here. We'll go with a D20. Okay.
I mean, there are entire religions focused around fearing things that you admire the majesty of.
So, big D20. Okay.
Ooh.
There are some problems with it. So, the red is usually to denote when there's too much of an overhang. And actually, if you look at it, I think it's like 60 degrees or something. I can't remember the exact number. But I think this is within tolerance, which is okay for now.
Are all overhangs of that measure going to be bad, or is it just when there's so much distance without a support?
It definitely depends on a lot of things. And sometimes the only way to answer that is to just print it and see if it works. So I can hit slice. And what's going to happen is it's going to basically figure out all the layers that need to print. So if I zoom in really close, you can kind of start to see every line that it's defining.
So it basically converts a model into some compatible pile of G codes that approximates it closely enough.
Yes. And so I can actually slice through here and look at all the layers as it goes.
The question is, can we make it heavy enough that we can use it as a murder weapon?
So what you could do is stop it halfway through the print or something. I don't know, fill it with sand. Stop it at I guess you'd stop it at like the very end of the print right here. And then, I don't know, fill it with sand or something. That could be kind of cool.
Concrete. Let's do it.
The thing that gets me with it is I thought the way that it generated layers didn't allow for any, I guess, material transparency between layers.
Well, so there's ways to stop the machine itself, and then you could fill this in with something yourself.
Just make sure not to move it at all.
Yes, you cannot move it at all.
Thankfully, most of the time it's stuck to the bottom if you've like hairsprayed the glass beforehand.
So yeah, sometimes the build material, some machines use glass. There is a different material. I can't remember exactly what it's called, but it has a little bit of a more textured surface, and it's kind of like a rubber mat in some ways. And I love it because it always adheres to the build plate, and I never need to spray hairspray down, and then I can just bend the build plate because it's like rubber and it just pops off.
Oh, that's nice.
I'm also not a huge fan of the texture that you get when you use glass because it makes a very flat layer because it's glass. I kind of like the little bit of texture because then it matches the other layers that all kind of have a little bit of texture.
Makes sense.
But okay, so we've talked a lot about G code, so I think we can dive into it. So I'm going to save this to file. The other things to note is it'll also give you some estimations for how long this is going to take. So this one estimates 4 hours and 8 minutes, and it's going to use 48 grams of filament, or 16.2 meters. Wow. Did it save to drive? Okay, whatever. I'll save to file. Yeah. And we'll save it on my desktop. And we'll call this B20.gcode. Okay, so let's look at some G code. Should be on here. Yep, here it is. Let's open with. I think there was actually an extension for Visual Studio Code because I actually did a little bit of editing of a G code file for one of these projects. So here, it opened on one of my other screens. Here is all the G code. How many lines?
Oh boy.
112,000 lines.
Look at that right side. Look at
All
that.
handwritten.
All handwritten.
Yeah. Well, actually, here, I wonder if I can. I have a program.
Oh goodness.
In Python that I wrote to do some editing of one of these types of files.
It just is telling you to go to different coordinates, right?
Basically, the majority of it, if you look through, it's a G1 command. So if you look at it, it's very similar to assembly, where you have an instruction and arguments to go, or operands, whatever you want to call them. And most of them are, the G1 command is a move command. It's move to an X position, a Y position, and an extruder position, because you have to tell how much of it to extrude. And that's really the only kicker, is that now you also have to think about the plastic. And all of these are absolute positions. And so what I did for one project was, well, I want to have a 3D print and then have the nozzle go up, back, push the 3D print off the build plate, and then start a new build without ever stopping.
That's really cool.
But the problem is, so this code is in absolute values of the extruder. So I wrote a Python script that goes through and then finds when you need to update the, like, because the second print, we're further along in the extruder. By the time you get to the end of this, you're at, whatever point along the extruder, like 3,500. And then it changed the first extruder value of the next print to whatever it needed to be, and then updated it throughout the whole thing in Python. That was fun.
Did it work?
Yeah, it worked. But I never actually got to print it because it was for the headbands, but the headbands stick too much to the build plate, so I was afraid it was going to break everything when it tried to rip it off.
Just try it. I want to see it.
So the idea never stuck.
Actually, with the D20 dies, it would probably work pretty well. But yeah, so this is G-code. You really don't have to be that scared of it, and there's a lot of other commands within it. So, and actually, a lot of these they put like nice little comments in it of like what it's printing. I think there might actually be a comment when there's a comment where it tells you what layer you're on, which is nice. So if at layer 60, you could go in right here and start adding in, add command to pause the printer. And so you could write code in it to pause the printer or do other things that you want. So it's a very niche use case to ever actually need to go in and edit. A lot of those settings you can find and change within Cura or within your slicer of choice. So yeah, I think that's everything with kind of the slicing and making the G-code. Pretty much the majority of G-code is really just move to this XY position and it put out some plastic. And then occasionally at every layer, so where was that last layer? There will be one command to move up one layer. Let's see, can I find it? There's like a Z. There it is. The 1Z command to move up on the Z-axis. Yeah. So any questions about the slicer or the G-code?
Not in particular, no. I guess, so you said that each of the G-codes is an individual, like say G0, G1, G2, etc. are individual commands.
Yep.
So I guess why was it written in this sort of way? It seems like it's expressly against the writer or the user.
Well, you're never writing G-code.
I mean, that is true.
It's probably just easier to automate making the generation of
Yeah.
the code.
Yeah.
Okay, that makes sense.
I mean, how else are you going to express I mean, really all you're doing is having something move around in space. There's only so many ways to express that. And this is kind of the standard, and it's pretty similar to like other CAD style things of there's commands and they basically just tell you to go to locations in space.
Okay, yeah, that makes sense. I was just really curious about it.
Oh.
Can you make a Doom port using G-code?
You say
No.
this like you don't already know the answer.
There is one interesting thing when I was trying to figure this out. You unfortunately, at least in the printer that we use with the software it has, it really doesn't have like memory locations to do things. So like you can't do like for loop and stuff like that, which was kind of annoying. But
No variables.
I mean, that's just...
It's not really designed for humans to touch.
Yeah, it's not really designed to run a program. It's designed to just iterate through a series of commands. So, You can't get everything. You can't get everything.
Sometimes you have to make some sacrifices for the people you love. And by the people, I mean the plastic models that are going to be used for completely material purposes.
Yes, they are. Yes. Yeah. I think that covers just about everything for that. I did the live demo. Wow, that was great.
I don't know. I kind of like the idea of using an infinite loop to 3D print an infinite.
Yeah, that would be fun. I mean, there's the problem of the fact that you're gonna have to stop it every so often to like put in more plastic, and so you really can just copy and paste. So a Control A, Control C, go to the end of the file, and then Control V, and you know it's got a second print now. Of course, all the extruder values are wrong for the second print.
And just do that a few thousand times.
Yeah, I mean realistically, and let's see. It's this, and then GitHub. I think it's on my GitHub in my playground.
Nice picture.
Thank you. Where is it? I think there's one for 3D printing. Oh, it's G-code edit. And so this goes through, it finds my G-code file, zoom in. And it goes through. First, I think I skipped through the first 110,000 lines of the thing because I already knew that was the first print. And then I went through the line, split it, looked for ones that contained extruder commands, and then I edited those extruder commands, put them back together, and wrote them back to the file. And that's what I did. And I closed the file at the end. And then this would go through and edit it. It was great.
That's pretty sweet.
I mean, there were a lot of shortcuts I could do because like I knew exactly how many lines that I didn't need to go through. So obviously this isn't very modular. But I mean, there's very few times you're doing this, so it didn't really need to be modular. That was kind of a fun one. Fun little exercise. So yeah, I think that's just about everything. Creating the model. So the next step would be, if we're working backwards, well, how did we get the model in the first place? And as a lot of you pointed out, you can get 3D models from the internet using places like Thingiverse, which has recently been going through a lot of updates. So sometimes it's been slow, but it looks like they're doing a lot better now. As you can see, people make a lot of very cool prints that most of them are free and you can just download them. I've seen things where people made the entire, this is a metric screw, a measuring device for screws. That's cool.
I like that.
I've seen ones where it had the actual models for all the screws, all the metric screws. So you could 3D print screws. So there's Thingiverse. You can really just Google 3D print. I don't know. What do you want to 3D print? A banana. Yeah. Banana model. Oh, why are there so many? And then if you just click on the first one, you can find files.
There you go.
It's not that hard. It really isn't. But let's say you want to be a little more advanced and make your own. You have a couple options. This is just a couple. I have this link, and I'll drop a link to this whole slideshow after this. I personally like FreeCAD. One, it's free. And the style on how you build things, and it's like objects, and you either add them together or subtract them apart, is for a programmer is pretty intuitive. Because it's like union these two objects together, and it'll literally just say like and them together or them, or cut one from the other. So it's intuitive if you know how those operations work.
That's actually really cool.
Yeah, so that's my personal favorite. If you're more artistic, Blender seems to be the kind of go-to for more artsy people. There's free versions of Blender, but it has a very steep learning curve. All of these have a learning curve. FreeCAD, it wasn't too bad. Blender, it's pretty rough. I think Tinkercad has the lowest learning curve, but it's also the simplest. So your mileage may vary with it. And so these are the three kind of mainstays. Like when you see people on YouTube talking about how they make their models, usually they're using one of these three. If they're not, they're using one of these two, which both cost money. I like open source software, so I'm going to stick to the free stuff, even though Blender's not open source.
Okay, there, Richard Stallman.
You can get Fusion 360 for free.
You can? I was looking for some stuff, and it was like there was like a student price, but there might be free stuff.
I have Fusion 360 on my computer because I have Eagle.
Okay.
Autodesk has their student licenses.
Nice.
That's an interesting use case.
There's also SolidWorks. I have heard a lot of good things about Fusion 360, so if you can find it, then go for it. I just really, it comes down to this: you pick one and learn it, because you can kind of do anything, kind of the same things in each of these, kind of, and so just learn how to do it in one of them. That's kind of really all you really got to know. You pick one and learn it, and I mean, when you get good enough, you can make whatever you need to make. So
Posting it in chat.
Oh, thank you. I'll put it in the slideshow as like a note. Yeah. So I know I didn't go into much depth, but for modeling tools, I feel like they don't necessarily need that much depth, just because it's very specific for each one. So,
question: if you can use Blender, could you use 3ds Max?
Basically, you need something that can export to a file that you can then load into your slicer. So if it has the ability to export, usually an STL file is the common format.
Okay.
If it can export to that, then you're good. Sometimes you might need to, like, if it is one of those programs, then you might then maybe whatever it exports, you can load into one of these and then export it to the final slicer when you're ready to print. So there's definitely workarounds in all of these for whatever you're trying to do. And I will take this and put it in. It was down here. And there. Okay. Yeah, that's my advice. Pick one and learn it. So that leaves 2 steps. And I'm not going to go to idea because I like to think that one's semi-self-evident as well. So we will look at how there's going to be problems when you're printing. So how do you fix them? And really, it's figuring out where does the problem stem from. So as we kind of went through, there could be problems with the print. Maybe it had overhangs, so it was like kind of falling apart as it was printing. And it was just a big mess by the end. So maybe you need to go back, may print it slower, may it needs more supports, which you could edit in the slicer. Or maybe it's not cooling the plastic fast enough, and maybe you need to strap some extra fans onto your 3D printer. There's a couple other things that could be happening. Maybe the layer lines look really bad, and may you need to go back, print them thinner, or maybe you can just soak your plastic part in acetone when you're done. I've seen people do that to kind of smooth it out.
Yeah, I know that my friend, he got a Prusa MK3 and he got the one that was manufactured. That was real hard for him to get calibrated.
Yeah, calibrating can be a problem too. Making sure that everything's level, and sometimes the build plate itself, a lot of times it isn't level within itself. So there might be a dip somewhere in it, and that can cause a problem if you're trying to be really precise. In which case, then the problem is you need a better printer, and that's an annoying problem to solve. Other things, I kind of mentioned this a little bit. Sometimes maybe it wasn't the problem wasn't the print itself, it's how long it took or what things were annoying about it. So maybe you need to print it at a faster speed, or maybe you can go back into the model itself. So this is going back another step in the process and trying to edit the model to remove the complex parts where it's having to move around a bunch. It's a lot quicker to print a straight line than it is to print a zigzagged line. So maybe that's one thing you could do. Maybe your print needs to be stronger. And so there's a lot of different ways you could go about that kind of thing. Maybe, so if we look at the sample, if we zoom in around the edge, I don't know how well you can see it. Let me cut down a couple layers. But essentially, when you're going around the edge, usually it'll do a couple of passes all the way around. So make a couple perimeters. Sometimes you might want to bump that number of perimeters up. So that's called the shell. And so there's like wall thickness, the bottom layers. You can set how thick all your walls should be. So maybe you need some thicker walls. You know what I mean?
Thickest walls.
Thickest walls. Like maybe like yeah. Yeah. Mm-hmm. Yeah, sometimes you need to like make it a solid. Rarely do you need to make it a fully solid piece of plastic. Other things are may you need to use a different filament. Different types of plastic are more or less strong in certain scenarios. So maybe looking at that. The other thing would be more supports of the model itself. So maybe you have to design your model differently. In which case, making a stronger print really there's a bunch of different how far back in the process do you really want to go, and you got a lot of options.
Do you know the pluses and minuses of using PLA versus ABS or vice versa?
The biggest one that I remember off the top of my head, I believe ABS has certain chemicals it releases as you're printing. And so you kind of need to print it like outside or have like a vacuum to siphon off some of the chemicals.
Can you even do
like it just releases fumes? It's not terrible, but it's not the best. And I think it's better for I can't remember if it's stronger or if it's just longer lasting. You'd have to look that one up.
I think it's longer lasting because PLA is made out of corn, so it's biodegradable in certain environments.
ABS is also better with temperature. I remember I was going to make vapes with my friend. We were considering, which one would handle battery heat, all that sort of thing with vaping. And we landed on ABS, if I remember correctly, because it was better for temperature.
Gotcha, makes sense.
Yeah, each of them will have kind of that different temperature range for what they're going to be printing. And sometimes, even within one type of material, each manufacturer will be a little different, which is kind of annoying. And that's kind of the process of going back and it's like, well, what was wrong with my print? Was it that, you could use the same settings from one spool of filament to another and it'll come out completely different on the same machine, which is kind of annoying, but it definitely allows you to go back and edit different parts of the process.
The Fab Lab, I don't know if you guys know or not, but they have a carbon fiber printer there.
Really?
Yeah, it's obviously going to be really expensive if you use it, but I think the bed's like 8 by 6 inches also. I don't know how tall,
That's a pretty good
but
size, isn't it?
yeah. And then I have a bunch of other ones too. They're in like a special room locked up that you have to ask for, but
Like special
exist.
materials, or just faster or thinner or more fine print?
So the ones that they have locked up are the ones that are like where you fill in a powder and then it lasers it and then it prints it that way instead of
yeah.
extrusion. Because those are like the multi-$100,000 machines.
Oh wow.
Yeah.
Yeah.
So what we mainly looked at was, so this process is the FDM printing, which is, I had to Google what that stands for. Fused deposition modeling, where you're putting down some material, but there's different where resin printing is a good example of this kind of style. Where instead of printing a layer at a time, it's essentially once printed kind of upside down, and the build plate it's going up. And so in this little well here is resin, and there's a UV light. And so the UV light hits the top of the pool of resin as it's connected to the build plate, and then the UV light will harden the resin, and then you move up one layer, and then you use the UV light to harden the next layer and keep going and kind of pull it out.
That's weird.
This is it's more expensive in some ways, pretty much in most ways. And the other thing is, it's resins. You have to like do extra things after it's printed to like clean it and handle it. Like you have to wear gloves as you do all this, which is annoying. And there's other stuff you have to do. It's usually more expensive, but the one cool thing is, well, you're cooling it with a laser. It's usually going to be a little bit more precise than doing like this. And the parts you can make because you're doing it that way, or you can do other things. So, yeah. So those were all things you could do to go back and fix your print. You can really go back to any part of the process to, make changes that could, affect your print. So there's a lot of variability. There's a lot of variables throughout the whole process that you can always go back and change. And if you're printing small parts with cheap plastic, that's 10 cents to go back and try it again. So that's not too bad usually.
Yeah, prototyping would be a lot cheaper if you were using a 3D printer.
Yes.
I think they also make ones that you can 3D print circuit boards too.
Really?
That's nifty. Another cool use case was at my work. They had these. Dang it, I forgot the name. They're the CMM machines where they measure a part. So they have this thing that they've manufactured, and it's a finger that comes down and pokes this part in a million different spots that the engineering team has defined, so that it can determine if it's all within tolerances up to like a micron or whatever it is. And so they used to have these big giant metal fixtures that would hold these things perfectly in place. But for some of them, what they realized was they don't need to do that anymore. What they did was they 3D printed these fixtures, and so now you can just bolt a post to the bed of the CMM, and then you can just put these 3D printed holders on them, and then you set the part in that, and it holds it well enough so that the CMM can measure the part. And so it's kind of a cost savings thing, so they don't have to keep, like, if they ever had to repair or I don't know, they don't need to buy these giant metal things and get them specially machined anymore. So they can just 3D print a part for like 10 cents.
Yeah, that's cool. Yeah, there's plenty of uses. The only thing that's kind of the downside is it'll take 5 hours to print it.
Well, I saw something with the extruding one, how it could work a lot faster because it worked on a layer by layer instead of a point. It could actually print an
with
entire
the laser.
layer at the same time. Yeah.
Yeah.
So I had actually seen a concept, or it was a really cool company that had it. It was a really expensive one, but
Yeah.
they were actually theorizing the quality based on the quality of their prints and how quick it was. You could have something like a car manufacturer could just print a new handle for your car because it was fast enough and quality enough that if you wanted a replacement part like that, you could just do that, which would be amazing.
That's pretty cool.
Yeah, that'd be cool. The only thing with resin to think about with the speed of the overall print is you have to do all that. There's a couple extra steps for cleaning it off, which shouldn't take that long, but something to keep in mind.
Do we
A
know
lot
if
of
there's
times
any?
with like the FDM printing, you can just leave it overnight and then the next day you have it. So
Do we know if there's any like resin printers with multiple lasers instead of just one? Because wouldn't that also that'd be kind of interesting, you know? Like
yeah.
2 lasers going at the same time.
Well, I'm wondering if it just like shoots, if it just moves the laser around really fast to like cool the
That's true.
I'd have to look into that.
It would have to depend, yeah, on the resin and how long it takes.
Yeah.
And for the normal extrusion method, for these types of printers that we've been talking about, I know there are double head printers where you've got two sets of filaments being pumped out at the same time. Now those are that's just like, two hands are better than one, building it faster kind of a thing, right? You can't like I don't know, like swap out, like have it printing on one for half of it and then switch colors the other half. It's a both kind of a thing.
Yeah. Yeah, no, you can have actually the best use for one of those that I've seen, which is really cool. Have one head with a water soluble plastic and another head with the normal plastic, and you print all your supports with the water soluble plastic.
Oh, that's cool.
It might not be water soluble. I can't remember what solvent you could use to melt it, but so then you'd print all your supports and then you just like wash the print and the supports would come off and you'd have your piece.
That's really neat. No sanding required.
Well, there's still some, but not nearly as much. Yeah, there's a lot of cool things with that. And you could do like 2 colors for some, like, whatever reason. Usually 2 material is when it's really cool. But yeah, those are a bit more expensive. So yeah, fixing prints and doing things, you can go back to any step of the process and there's a way to fix it and change it to update your print. So the last thing would be, how do you pick your idea? And so I thought you got to end on some cheesy quote. And I thought this one was pretty good. Creativity is seeing what others see and thinking what no one else has ever thought. There's plenty of uses for 3D printing, and sometimes you just have to look around for it and find places to use it. So, yeah. That's
awesome.
it. That's the whole thing. That's 3D printing. You're basically experts now.
Fantastic. Thank you, Joey.
You're welcome. I will share this.
Oh yeah, and I'll put the link in the YouTube video when I upload it right after this.
Awesome. So yeah.
Sweet.
Hope you enjoyed. You feel like you learned a lot about 3D printing now?
Thank you very much for sharing this with us.
No problem.
Yes, thank you very much.
Yeah.
Oh, and everybody knows that that if you don't have the ability to buy a 3D printer, yeah, Ben said the Fab Lab, that's a little bit closer to home, but also the Think Box, you can use the printers there for free. You just have to pay for your own filament, which is like 5 cents.
10 cents.
Yeah. Or you can mooch off your former roommate like I do.
You could do that too.
Wait, where's the Fab Lab?
Main campus LC.
Yeah,
okay.
It's in the not the Stalker Center. It's the Engineering Campania Engineering Development Center. That's what it is.
Is that the place like right next to the cafeteria?
And the basic requirements
yeah.
were that we had to be an LCCC student, or that we at least had to be a Lorain County resident, right?
Something like that, yeah. And then you just have to go in and sign in and basically just agree not to break their stuff. But they've got stuff like oscilloscopes, power supplies, all sorts of stuff. It's not just 3D printing.
Laser engravers, pry.
I think they also have a CNC machine.
Oh, that's awesome.
They do. I know this because one of my friends works in the fabrication lab, or used to before, LCCC and UT decided to lay everyone off.
That's another cool thing that the Fab Lab has, or not the Fab Lab, but the ThinkBox has, is they've got. I've never used it, but I think they've got like a 3D arm scanner that you can use to like just go around some object and make a 3D model of it.
Is the ThinkBox like a makerspace somewhere?
Yeah, it's a makerspace at Case.
Ah, okay, yeah. Okay. It's kind of like the Fab Lab then, but the Fab Lab's I think done it in partnership with MIT, isn't it?
I am not sure.
Not sure.
I think
if it is, then that's new information to me.
I know that the original Fab Lab was done at MIT, and I'm pretty sure that the stuff is done. I believe I took a class when I was still going for mechanical engineering. I had to take a blueprint reading class, and we got a lot of stuff from the Fab Lab, and we talked about it for a while. Someone came and talked to us.
That's pretty cool. All right. Well, if nobody's got any other questions, that's a good wrap. We'll be back. I think what I'm going to do for the next meeting is I might try to get Professor Nolan, depending on how busy he is. I don't know how busy he is with embedded systems, but he said before he picked up the class that he'd be willing to give a lecture to us of some sort. So if you guys have anything that you want him to lecture on, let me know, and I'll ask.
Farming.
Huh? Farming?
Is your recording still on?
Yeah, the recording's still on. I can stop it.
Okay.